In this lesson, we'll analyze the synthetic dataset. Here are the concepts we'll cover. We'll start with some summary statistics like totals per day. Then, we'll compute correlations between different pieces of data to understand where to look for patterns and to develop some intuition. Finally, in this step, we'll draw some initial conclusions. If you've lost your notebook, or if you're just starting the class from this lesson, access a starter notebook for lesson 6 from alvin/data101/notebook6. Once you access that URL, you should see a page like this one. Go ahead and click on File and save a copy in Drive. I'm going to click on X in the top left to close that navigation bar. Once you're on this page, on the very top, click on Runtime and select Run All. Wait for all the cells to run. You can tell once you've seen the output of all the cells. Go ahead and from this cell, start by computing several summary statistics. For example, compute how many days the dataset spans. To access the dates in the data frame, use df.index. Go ahead and type in .max to get the last date, then subtract the first date using .min. Run the cell, and here we get a time delta object of 100 days. The second summary statistic is the number of page views per day. For this, we'll need to define a function. The function will count the number of events that occurred on each day. Start by defining the function name events per day. This function will accept one argument called df. Add parentheses, type in df, and make sure to add a colon at the very end of that line. Go ahead and hit enter. Once again, Colab automatically adds 2 spaces for us. First, type in datetimes equals the df.index. This is the data frame df. df.index retrieves the datetimes for each view. Next, define a new variable, days is equal to datetimes, and use .floor, add your parentheses to call the function, and then pass in a string of lowercase d. .floor converts datetimes to dates. Type events per day is equal to days.valueCounts. Value counts the number of times that each date appears. In other words, we count the number of views per day. Call return events per day .sort index. This will sort the counts by the day. Don't worry, this function seemed like a lot. The most important takeaway is not to memorize the code. This code is perfectly Googleable. Most important is that A, you can read the code and roughly understand what it's doing. Then B, that you know what to Google for in the future. In this case, to count the number of views per day, we counted the number of rows per day in the data frame. Let's see what our function returns. Define a new variable, views per day. Set this variable to the return value of our above function. Remember, this function takes in one argument, which is the data frame of data. Output the variable's contents. Run the cell, and here we get counts of views per day. Next, define another function that filters the data frame to contain only rows that resulted in a click. Start by defining the function name getClickEvents. This function will accept one argument called df or the data frame. Again, don't forget your colon at the end of the line. Hit enter, Colab adds 2 spaces for you, and now type in selector equals to df square bracket and the name of the column that contains the click information. Here, clicks is equal to df and type in selector. Now, go ahead and return the new variable that you've defined, which is clicks. This returns the data frame with only the rows that have true in the selector. And the rows that have true in the selector are the ones that resulted in a click. As a result, this function returns a data frame with only the rows that resulted in a click. Go ahead and run the cell. Now, use this function to get only the rows with clicks. Define clicks equals to getClickEvents and pass in your data frame. Define a variable clicks per day equals to, and just like before, we're going to count the number of events per day. Finally, output the variable's contents and run the cell. And here we can see a number of clicks per day. To see just the values, use the attribute .values. Unlike with methods, you don't need parentheses to access an attribute. Type in clicks per day .values. Again, no parentheses are needed to access this attribute .values. Go ahead and run the cell, and here we get all the values. Now, we need a sanity check. Here, we want to check that the number of clicks per day is less than or equal to the number of views per day. Let's go ahead and check that now by typing in clicks per day dot values is less than or equal to views per day dot values. Go ahead and run this cell. Now you can see that all of these are true. Looks like the sanity check passed. Nice work. Next, let's compute the correlation between the features in our dataset. If you recall from your statistics or probability class, correlation tells you how one feature changes when another feature changes. Say you have two features, page load time and video watch duration. As page load time increases, you expect less people to watch the video. In order to check and compute correlation, go ahead and type in df.core with 2 R's. Add your parentheses to call the function and run the cell. This core method will compute correlations between all pairs of features. For a sanity check, ensure that correlation coefficients below reflect our intuition. We expect that as page load time increases, the probability of clicking decreases. We can see that in the first column, second to last row. Sanity check has passed. Another interesting thing to note is that time spent looking at the pricing section of the web page is very, very weakly correlated with clicking. You can see that the correlation between pricing and clicking is 0.10. On the other hand, video watching is, relatively speaking, highly correlated with clicking, with about 3 times the value. By examining the correlations alone, it appears that Webpage A with the video is more effective. Finally, let's compute the click-through rate, or CTR, for each landing page. This tells us the ratio of clicks to views. Our ultimate goal is to recommend a landing page that will maximize the click-through rate for potato time. Start by computing a selector. Before, we used has clicked, which is a column that already contains true or false for each row. So we can write the following to check if a row is for Webpage A or not. df, square bracket, and select the web page column. Now we want to check if this column is equal to A. If I run the cell, you'll see that the entire column is full of trues and falses. Perfect. We can now use this to select rows in the data frame. Now we can use this selector. Go ahead and copy that, and down below in the next cell type in a new variable, views A is equal to df, square bracket, and then paste in the selector. This will select all rows such that the column web page is equal to A. Next, repeat this for Webpage B. We want to obtain all views for B. Set this equal to data frame, and again with the same selector except for the Webpage B. Type in views A has clicked dot mean. Recall from previous lessons that we can call print to actually output this value. We're going to do the same thing, but now for views B has clicked dot mean. Go ahead and run the cell. And this appears to give us the opposite conclusion. Remember from before, looking at the correlation values, Webpage A looked better. However, this shows that the click-through rate of Webpage A, 0.28 or 28%, is much lower than Webpage B's, which is around 40%. The click-through rate suggests that Webpage B is better. These two initial conclusions appear to contradict each other, meaning we'll need to dig deeper to figure out why. These are the concepts that we've covered in this lesson. And here's a tip that we've mentioned several times in this lesson. Sanity check often. Common mistakes include improper filtering, typos in your column names, or even unclear column names. Sanity checks help you identify, isolate, and address these mistakes quickly. In sum, here are our initial conclusions. We first examined the correlations and found that video watching and clicking are highly correlated. We also found that pricing reading and clicking seem weakly correlated. This suggests that the video, or Webpage A, is more effective. However, we computed click-through rate and found that Webpage B has a higher click-through rate. We sanity checked all of our calculations so far. So why the discrepancy? This sounds like a contradiction we'll need to resolve. If you'd like to access and download these slides, visit this URL. Make sure to save your notebook by hitting File, Save. And next time, we'll code some visualizations, resolve this mystery, and prepare figures for your final pitch.